Hello, ladies, Mr. Sullivan. Today we're going to be looking at lesson 3-9, the distance formula. Today's learning target is I can apply the distance formula to determine the distance between a given set of points. This is a formula you're going to have to memorize, but let's see how we prove this formula. So we're going to be using this formula to find the length of any given line segment. So if I look at my visual right here, I have a right triangle. I can tell I have a right triangle, so what I'm going to do is I'm immediately going to draw in my right angle. So I know that in a right triangle, the side across from my right angle is my hypotenuse, and then my other sides can be called A and B. So I know in the Pythagorean Theorem, I can do A squared plus B squared equals C squared. If I look at my image, though, I know what my side lengths are. I have an x2 minus x1, and the reason why I'm saying x2 minus x1 is because that's the distance between my x values. So I can substitute that in for A. So I have x2 minus x1 squared plus y2 minus y1 squared, and that's equal to c squared, which in this case is a good old d. So I now have d squared. Thing is, though, I want to solve for d, right? So what I'm going to do is I'm going to take the square root of both sides because there is a square attached to my d. So I'm going to take the square root, and I get d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's your distance formula. You just did your first geometric proof. And you've got to memorize it. So here's how the distance formula works. Given 2 points, x1, y1, and x2, y2, the distance d between these points given by the following formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, please, please, please do not let those subscripts scare you. They only indicate that there is a first point and a second point. That is, that you have 2 points. Whichever one you call the first or second is up to you. The distance will be the same regardless. So what we're going to do is we're going to find the distance between the following set of points. If I look at my first example, everything is negative, so pay very close attention to that. We got to be careful with those negatives. So I have -6, -10, and -2, -10. The first thing I'm going to do is I'm going to write d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to color code it, that way we see everything. So distance is equal to the square root. I have x values, and then I have y values. So if I look at this problem, I'm going to do -2 minus -6, and then square it. And I'm going to add y2 minus y1, or in this case, -10 minus -10 squared. I'm going to keep color coding, so I'm going to keep it green. Now I do this using my calculator. I can type this whole expression into my calculator without the radical and just get an answer, or I can do some mental math. Let's do some mental math just to get our head into that mindset of math. Well, -2 minus a -6 is 4, so I have 4 squared plus, well, -10 minus -10 is just 0, so I have plus 0 squared. So I have distance equal to the square root, well, 4 squared is 16, 0 squared is 0, and 16 plus 0 is just 16. So I have distance is equal to the square root of 16. I can type that into my calculator, and I'll get 4 as my final answer. So I can say my distance is equal to 4. And that's how you calculate the distance. Now, for some of these questions, you will have to write it to the nearest tenth, where you simply just type it into your calculator and you might get a decimal. And then for some of them, you're going to have to do it in simplest radical form. Let's look at our next example. We have distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. The first thing I'm going to do is I'm going to label my x coordinate. So I have my 3 and my 2, and then I'm going to label my y, so -3 and 7. So I can say distance is equal to the square root of x2 minus x1, so I can say 2 minus 3 squared plus 7 minus negative 3 squared. Now I'm going to write distance is equal to the square root. 2 minus 3 is negative 1, so I have negative 1 squared plus 7 minus negative 3 squared, which is just a 10 squared. Negative 1 times negative 1 is a good old 1, so I have distance is equal to the square root of 1 plus 10 squared is 100. Now I do 1 plus 100, so I get distance is equal to the square root of 101. And I cannot simplify that. And that's your final answer. So that's it for today. Don't forget to complete your independent practice where you're finding the distance between 4 pairs of points. If you have any questions, email myself or Ms. Colarundo.